Welcome to qiphyedu. Today we'll be looking at computer science, paper 11, October, November 2021. Right, so let's get started. So, okay, this is the first question. Draw one line from each binary value to its equivalent value on the right. So, 8 bits is basically 1 byte. This is basically the answer for 8 bits. You need to remember that for 1 byte, every byte equals to 8 bits. And then 8,000 bits, this can be calculated by dividing, you can actually just divide it like this. So we have 8,000 bits. So we need to convert it to bytes, because here on the right hand side, it's all bytes. So we need to divide it by 8. So we get 1,000 bytes. But here there's no 1,000 bytes, so we need to find the closest thing to it, which means that we need to divide by another 1,000. So after dividing by another 1,000, um, we get 1 kilobyte. So okay, so that'll be 1 kilobyte. Okay, so we need to remember this. First we start from bit, then we move on to byte, then kilobyte, then megabyte, gigabyte, and terabyte. This is different for numbers that are divided with base 2. So like, for example, instead of kilobyte is kibibyte. Difference between kilobyte and kibibyte would be, if you divide the number byte by 1,000, you get kilobyte. If you divide it by 1,024, you get kibibyte, right? Because 1,024 is technically the number itself is calculated with base 2. So instead of kilo, you get kibi. B stands for, which technically can be referred to as binary, right? So that's the difference between these two. So here, let's look at the next one, which is 1,000 kilobytes. So 1,000 kilobytes, okay, same thing. We need to divide it again. Although technically we can just look directly and then we can know the answer for some people who have already, students who have already looked through like almost the entire book, I guess, or do a lot of exercise. So this one we divide, we get 1 megabyte, because that's the next value after kilobyte. So it's 1 megabyte. So yep, 1 megabyte, right? And then the next one would be 1,024 megabytes. Yep. So this is like the thing that I explained before, base 2. So this will be 1,024. So now we need to convert it to a smaller number, so that'll be gigabyte. So 1,024 divided by 1,024, you get 1. So this is 1 gigabyte. So 1 gigabyte, which should be here, right? And then 8,192 bits. Okay, 8,192 bits. So we need to convert it to bytes, because on the right hand side is all bytes. So 8,192 divided by 8 bits. So this will be 1. So okay, so 1,024. So this will be 1,024 bytes, which also translates to 1 kibibyte, if I'm not mistaken. So 1,024 bytes converted, so we get 1 kibibyte, right? So yep, 1 kibibyte, right? There we go. This is the answer for all these questions. So for this question, so you can see that 1 gigabyte and 1 megabyte is unused. Okay, perform the following binary addition, show your workings, right? So 0 plus 1 is 1, 1 plus 1 is 10, so we need to move the 1 to the left hand side, and 1 plus 1 is 10 as well, so this is also 0, so we put 1 here. 1 plus 1 is also 0, so we move the 1 to the left digit again, so 1 plus 1 is also 0, move to the left, and you can see here that there's already 1 plus 1 in this row of digits, this row of this column. So 1 plus 1 equals to 10, and then with the 1 from the right hand side, it becomes 11, right? So this is 11, so there's 1 here, and then we move the 1 to the left hand side as well. So here we put the 1 on this row, and then the final 1 on the leftmost bit. So this is 111000001. Yep, that's the answer for this one. And state how an overflow can occur when adding two binary integers. Okay, so if it's an unsigned binary integer, which assuming that that's the case because it's not listed here. So for 8 bits, the number, if you, let's say you add up everything, so this will be 128 plus 64 plus 32 plus 16 plus 4 plus 2 plus 1. Oh, sorry, 1, 2, 3, 4, 5, 6, 7, and also this 8. So when you add this up all together, it's 100, okay, 220, 8 plus 4 plus 2 plus 1, 16, then 2, 7. So total you get 255 characters. So that means that if you, let's say you add two binary integers and they exceed the value of 255, that means that there's overflow. So here we can just write the result is greater than 255. So this is how overflow occurs, is when the values exceeds the number of values that the binary the number in binary representation can handle, right? So now we need to convert hexadecimal value F0 into denary. Okay, so now we're going to convert this into denary. So let's just convert it directly using binary method, and then we convert back to denary. You can actually, there are many ways to do this, but I prefer to do this because I previously, for a few papers, I did the same thing as well, which is I convert it to binary and then convert back to denary. That's, for some reason, it makes me feel safer, right? So this is F0. So 0 is just basically 0, 0, 0, 0 for 4 digits. And then F is the last value of, it's the last value for, inside the hexadecimal number of numbers that hexadecimal, it's within the range of the hexadecimal numbers. So that will be either 0, 1, 2, 3, 4 until 9. And then starting from after 9, you'll be A until F. So A, B, C, D, E, F will be 6, and then if it's represented in numbers, there'll be 10 digits, and then from A to F will be 6. So add up together, you get 16. Right? That's basically how many numbers, what's the value that hexadecimal can handle, which will be 16. So F is 16, so that'll be 1111, right? So we get 111000. So technically, the right hand side, if you want to convert to denary, it's basically 2 power 0, 2 power 1, 2 power 2, 2 power 3, all the way until 2 power 7. But because until 2 power 3, it's basically 0, we don't really need to do anything on the right hand side. We can just assume that everything is 0. So we start with 2 power 4 until 2 power 7. So 2 power 7 is basically 100. It's basically 128. So plus 64, plus 32, and plus 16. So adding up together, we'll get 240. So this is the answer for hexadecimal value F0, right? And then we move on to the next question, question 2. Center, I don't know if I'm pronouncing it correctly though, so I apologize if that's wrong. Wants to maintain the integrity and security of data stored on the computer. Explain the differences between data security and data integrity. So when it comes to data security, technically it's to protect the data from actually resulting, to prevent it from having getting lost from the computer, like disappear. Like let's say the file is corrupted and all those, that's under data security. Data integrity is the accuracy and consistency of the data. So basically, data security is, technically you can say, is used to protect data loss, to prevent, or we can say prevent data loss, which is, I think, is much better in this context, whereas data integrity is used to ensure data accuracy and consistency. Right? So he or she uses both data validation and data verification when entering data on the computer. Describe how data validation helps to protect the integrity of her data. Give an example in your answer. So here is specifically for data validation. So data validation is only used to ensure that the data itself is relevant or reasonable. So we can just say that validation checks to see whether the data is relevant or reasonable. Example would be to check if data is data entered is correct. Like we have for data validation, we have like presence check, range check, and existence check, and all those. So in this case, checking if data entered is correct, we could technically say that check if data entered is in the correct form, right? So this would be existence check, right? So then we'll look at describe how data verification helps to protect the integrity of the data. Give an example in your answer. So now it's asking us to describe how data verification helps to protect the integrity. So data verification checks if data inserted same as original. So example of that would be double entry. So like for example, when you type in a password, you need to type 2 times. You need to type your password and then you retype the password. Ensure that the data is so-called correct with the original one, right? So that's how data verification works. However, data verification will still not ensure that the data that is originally on, let's say, on paper will be correct. But then at least you type in 2 times, so you're making sure that whatever you type is the same as the previous one, right? So let's move on to C. Two malware threats are spyware and viruses. Give 2 similarities and 1 difference between spyware. So both of these things are malicious software. And then both can run in the background. So you see spyware and viruses running, but the user normally will not actually know the presence of these malware or viruses to even begin with. So both can run in the background. Differences being virus damages computer data, whereas spyware accesses the data on the computer, which accesses computer data. Well, difference between these two, basically, viruses, it damages the data on the computer, but spyware is normally used to monitor someone's computer's data activity. So basically, spyware can be used to monitor the the data that is stored on the computer. So you can technically see inside the data without the other person knowing that you have technically the spyware is installed on their computer, right? So move on to question number 3. Question number 3 is about a logic circuit. So Okay, so now we need to assume this circuit as one, combined with this other circuit together, right? So in this case, you can see that A, B are connected to an AND, it's connected to an AND logic gate. So here it's A and B, um, A and B bracket, and then XOR, because this is an XOR logic gate, so XOR C, and then because these things are combined into one, so we need to put a bracket as well for both these. And then there's a OR logic gate after after the NOT gate and also the XOR gate. So on this side we need to put OR, and then there's a NOT logic gate for B, so we need to put NOT B. So in the end, the logic expression for this logic circuit will be A and B XOR C or not B. But you need to make sure that you actually put in the brackets to make it more easier to identify, right? Complete the truth table for the given logic circuit, alright? So, okay, so it says A, B, C, all of them are 0, so let's do that. 0 and 0, XOR 0 or not 0. So in this context, even though 0 and 0 equals 0 and 0 XOR 0 is 0, but because not 0 is equal to 1, so your x is equals to 1, right? So here for this one though, 0 and 0 XOR 0, XOR 1 or not 1. So you can see here 0 and 0 still equals to 0, but 0 XOR 1, so you get 1, and not 1 is 0, so 1 or 0, so it's 1. Okay, so let's look at the third one, 0 and 1 XOR 0 or not 0. So this one, 0 and 1 is 0. XOR 0, you get 0. So 0, okay, apologies, I did something wrong here. So I forgot that it's actually not B. So everything I look at, everything on the right side is now mixed up. So now B is also 0 on the right hand side. So 0 and 0 XOR 1 or not 0, so it's 1 or 1, so you get 1. Now 0 and 1 XOR 0 or not 1, so this one would be 0 XOR 0, so you get 0, so 0 or 0, you get 0. Okay, so now let's move on to the fourth one. So this one, remember it's B, so okay, let me move on to the next one. So next one is 0 and 1 XOR 1 or not 1. So 0 and 1 is 0, XOR 1 is 1, and not 1 is 0, so 1 or 0 you get 1. And then here is 1 and 0, XOR 0 or not 0. So 1 and 0 is 0, XOR 0 is 0, 0 or 1, so you get 1. And then 1 and 0, XOR 1 or not 0. So 1 and 0 XOR 1, so 0 XOR 1 is 1, 1 or 1, so you get 1. And then 1 and 1 XOR 0 or not 1. So 1 and 1 is 1, 1 XOR 0 is 1, and 1 or 0, so you get 1. Last one would be 1 and 1 XOR 1 or not 1. So this one, 1 XOR 1, you get 0. Or not 1, you get 0. So 0 or 0, you get 0. So this is how you do the truth table for the given logic circuit. Right? So this one, everything on this side would be A, and everything on this side would be B, and then everything on the XOR side would be C, and then for the NOT logic gate, that will be for B. Right? This is for B. Right? So you can identify by looking through the data given on the left hand side of the table to identify whether or not whatever we written down is correct or not. Right? So we move on to C. So there is one logic gate not used. So you can see here we have the AND gate which is used, the NOT gate which is used, the XOR gate which is used, and the OR gate. So there's technically there should be two more that is not used. So that will be either NAND or the NOR gate. Okay, so there's either NAND or NOR gate that is not used. So I'm going to use the NOR gate. Okay, so I'm just going to type right here NOR gate. So NOR gate will look something like OR. However, there's a circle. There's a circle. There's a circle after the, after you draw the OR gate itself. So that's how it becomes a NOR gate, right? So for truth table, so we need to write the output. So 0 nor 0 you get 1, 0 nor 1 you get 0. This is everything that is upside down of OR. OR itself it should be like 0 1 1 1, but this is 1 0 0 0, right? So everything that OR does, everything that OR outputs is the other way around for NOR gate. Alright, so that's how you get the output. Okay, question 4. Francis is starting his first job as a software developer for a multinational company. He has been advised to join a professional ethical body and describe the benefits. Okay, so this is for ethics and ownership. So what's the benefits? Technically we can say that this lets clients know that he's reputable, as his skills are recognized. Not only that, the ethical body can provide help and support if he needs legal advice, because it is part of the ethics and ownership thingy. So technically he can ask for support when it comes to legal advice, and attend training courses to enhance his programming skills. Right. So look at B. Francis is shown the software he'll be working on. He is unfamiliar with the integrated development environment he's required to use, and describe the ways in which Francis can act ethically in this situation. So what can he do? First, you can say that he can perform research on how to use the IDE. Secondly, he can ask for mentor to teach him methods of using it. You can technically add another one if you want to be on the safe side. Additionally, he can explain to the manager that he needs additional training, or he needs training for using this IDE. Right. So number two, a typical IDE provides debugging tools to support the testing of a program. So Identify three other tools or features found in a typical IDE. So in the IDE, there will be autocorrect feature in case you get something wrong. Let's say, for example, you want to type a command, but the command itself is of something else, then the IDE itself would autocorrect it to something that the IDE itself understands, but it's related to whatever you're typing. Maybe you type something wrong, it will automatically correct it to that particular word. And then if you did not complete when you type a program and you did not complete the typing of that particular command, it will automatically finish the last few characters for you. So that's auto complete. And then for most IDEs, especially if you use Visual Studio Code or Visual Studio Community or Notepad++ in general, there's also another thing called color coding. So when you look through the code, you know which is command and which is just plain text, right? So so this is the three other features that you can see in a typical IDE. And then Francis is part of the team writing a program. He finds an error that has already been tested, but he's worried about the consequences of telling people that there's an issue with the program. So explain the reasons why he acted unethically. So technically the question itself is asking you to explain why his actions is considered unethical. So in this case, we can say that, first of all, he didn't act in the best interest of the product. Because the error in the program may result in the program failing to operate correctly. Not only that, he didn't act in the best interest of the client, because if the program doesn't work correctly, the client if the act doesn't work correctly, they may lose potential clients, and may also result in a failing business. Basically, they will be let down because of the error lah. Basically, when if the program doesn't work, the client knows about it, and then the client may become disappointed, and so on and so forth. So that's why he didn't act in the best interest of the client. Right. So this is the two things that you can write. Right. Technically there are 4 points here, but so it's better to write more, because if you write more and it's logical, then there's a higher chance of you getting full marks. That you get a better chance of scoring full marks in case anything goes bad. Well, you're doing it in the best case scenario, right? So now let's go to D. French's team used language translators. Complete the description of language translators by writing the missing words. Right. So here we can look at the sentences on the that are listed down, and also the position of the empty spaces. So here we look at the first line. Are usually used when a high-level language program is complete. They translate all the code at the same time and then run the program. So they translate all the code at the same time. So the main word here would be same time, and then run the program. So this is the function of a compiler. So this is a plural form. And then they produce what files that can be run without the source code. So after they compile the file, they compile the source code, it can then be executed using something. So in this case, this will be an executable file. It's very common. You see on Windows computers, you see a .exe file or a .msi file. So the .exe file itself is technically the file itself that can be used to install the program without using the source code. And then move on to the next one. Translate one line of a high-level language program at a time and then run that line of code. They are most useful while developing programs because errors can be corrected and the program continues from that line. So this is the job of a interpreter because it translates one line of a high language program at a time. This is the function of an interpreter. So this is the interpreters, right? And then assemblers are used to translate assembly code into machine language or machine code. You can also say binary code if you want, but I prefer to write machine code. Right? So then move on to question 5. The JVO owns many shops that sell cars. He employs several managers who are each in charge of one or more shops. He uses the relational database cars to store the data about his database. So this database connects to all these tables, right? So let's move on to A. Tick one box in each row to identify whether each field is a primary key or a foreign key. So we look at the table manager. All right, we look at table manager. You see here that we have manager ID, first name, last name, date of birth, and wage. So we need to know that date of birth can be recurring. Like let's say two people can have the same date of birth, two people can have the same wage, two people can have the same first name, two people can have the same last name. So it's possible that all these could be same, but for manager ID it must be unique. So this is the primary key for manager, right? So we look at shop. We have shop and then we have shop ID, manager ID, address, town, telephone number. Same thing goes for this one. Telephone number could be the same, town could be the same, address could be the same, but manager ID and shop ID would not be the same. However, because manager ID is actually the main ID for manager, that means that the table shop actually took the data of manager ID from the table manager and integrated into its own table, which means that it is not a primary key but a foreign key because it's a primary key of another table. So in this regard, it is a foreign key. And then for car, the car itself is also a table. So you can see that there's registration number, make, model, and all those. Now, shop ID is part of shop, which is the primary key of shop. So it's actually used as a foreign key. So so it's not the primary key of this table. And then number of miles could be the same for some cars, model could be the same for some cars, make could be the same for many cars. So the only thing here that's different is registration number because each registration number must be unique, especially on every single for every single vehicle around the world. So registration number here is primary key for car, and then shop ID here will be foreign key, right? So this is the answer for this for A. Then we look on to B. Describe the ways in which access rights can be used to protect the data in JVS database from unauthorized access. So what we can do is have different accounts. So describe the ways in which access rights can be used to protect the data. So access rights give managers access to different elements. By having different accounts. Which have different access rights. Specific views can be assigned to himself and the managers. For example, managers can only see data for their own shops. Right, so they're limited to their own shops only when it comes to the data. Right, so now we move on to C. JVA uses DDL and DML statements in the database. Complete the following DML statement. Return the number of cars for sale in each shop. Right, so here, number of cars for sale in each shop. Right, so we are calculating the number of cars available. So we look up to the top here. The only thing that will make the number of cars you need here will be registration number. So we put in registration number. From where? So that will be from the table car. And then shop ID, because it's a foreign key. So it's a foreign key. So technically we can we need to group the cars by shop ID. So we can show how many cars are available at which shop and so on and so forth. So here we will just put in group by. Right, so this is the DML statement. And then complete the DML statement to include the following car in the table car. Right, so this will be insert into. This will be values because it's plural. So there'll be 1, 2, 3, 4, 5 values. Right, so insert into car, values. Right, so all these values here. It's already in ascending order, as you can see. And also it's compared to the, if you compare it with the data on top. Right, so then we move on to question 6. So there are two errors in the following register transfer notation for the fetch execute cycle. So here, let's see one of the main problems we have. So this one we can just look here and see what's actually wrong. So number one is okay because you are copying the content of the program counter into memory address register. That's correct. But here, if you look at 2, the program counter's data is actually subtracted by 1, which is wrong because for program counter, then the only thing that will happen to the value inside the program counter is that it's incremented every single time. So instead of PC content of PC minus 1, it should be content of PC plus 1. So here we'll just write line number 2 because it's from line number 2. Program counter should not be subtracted by 1. And it should be incremented. So instead of PC, content of PC minus 1, it will be content of PC plus 1. Right, so then here, it is at memory data register. So here it should be because this thing here is actually the content of the memory address register. So now we do not want the contents of the memory address register. We want the content of the address in the memory address register. So instead of, because what the MMR stores is basically the address of something. So now we want the data of the inside the memory, the address itself. So instead of content of the memory address register, we want the content of the address stored inside the memory address register. So that means we need to add another bracket outside of MAR. Right, so instead of just 1, we need to put 2, right? So this will be it should be contents of the address in the MAR. So here this will be MDR, MAR, like such. I think I got correct here, like that. And then move on to the next one. The following table shows part of the instruction set for processor, right? So we have the opcode and the operand. So now we move down and see each row will perform instruction. So here we see the current content of the ACC is this, and then we have the instruction and the new content. So this one here, it's all 101, right? So 101 is 1111 0000. So So here we need to execute the instruction and also execute instruction on the current content of the ACC. So let's do it on top here. So 11111111. So this OR101 thingy, this 101 is the address. So here 101 is 11110000. So 11110000. So it's all. So let's look from on the rightmost bit all the way to the leftmost bit. So 101 is 1, 101 is 1, 101 is 1, sorry, 1 or 0. So all the 4 bits on the right hand side are all 1 or 0. So all of them are 1, 1, 1, 1. Same goes to the left hand side because 1 or 1 is 1. So everything here on the left hand side is 1, just 1. So new content of the ACC would be 8, would be, all 8 bits would be 1, right? And then for XOR hashtag 15, because this is a hashtag, that means that we are just doing an XOR instruction with the current contents of the ACC and also with the number that is in the instruction. So hashtag 15. So it's not directing to an address, it's directly the number itself. So 15, we need to convert it into binary form. So that would be 1, 2, 4, 8. So this will be 0, 0, 0, 0, 1, 1, 1, 1, because if you add these numbers all up into denary, this would be 15. Alright, so we need to compare it with 0, 0, 0, 0, 0, 0, 0, 0, 0. So here is XOR. So 0 XOR 1, you get 1. 0 XOR 1, you get 1. 0 XOR, you get 1. 0 XOR, you get 1. And then for the left side is all 0 XOR 0. So it's basically just 0 for the left 4 bits. So it's 0, 0, 0, 0, 1, 1, 1, 1. Okay, so here it's LSR2. So hashtag 2. So we need to move it 2 times. We need to shift 2 bits to the right. So here we're removing 1 0, and then we introduce 2 zeros on the left. So this one is 0 0 1 0 1 0 1 0, right? So we can see there's 8 bits in there. So 0 0 1 0 1 0 1 0, right? And then N104. So this is another address. So let's look at address 104. It's completely 0. So 0 1 0 1 0 1 0 1 0 0 0 0 0 0 0 0. So here 1 or 0 is 0 0 0 is 0 and 0 is 0, 1 and 0 is 0. So basically everything here is 0, right? So the new content of the ACC is basically 0, binary number 0, right? So yep, so this is the answer for 6B, right? So now we move on to 7A1. Bobby is recording a sound file for his school project. He repeats the recording of the sound several times with a different sample rate. Describe reasons why the sound is closer to the region when the highest sampling rate is used. So this one we can just say there's a smaller time gap between the samples. This makes the digital sound wave more accurate. Alright, if you want to, you can also add another one, which is not only that, there are smaller quantization errors. Describe the reasons why the sound file size increases when the higher sampling rate is used. Because more samples are recorded, which increases number of bits stored. Right? B. Bobby wants to email the sound file to his school email address. He compresses the file before sending the email. Okay, so why does he compress the sound file? This is to reduce file size, which increases transmission speeds. It may also be because original file is too large in size. for email, for sending it via email, right? Okay, so let's look at 2. Bobby uses lossless compression. So lossless compression, technically, there are 2 types of compression. One is loosey compression, and another one is lossless compression. Right. So if you want to preserve the quality of the file, normally we'll use lossless compression. So for this one, we normally will use run length encoding. So here we can say where consecutive sounds are the same, the binary value. Actually, here we can say when, it's not where, the binary value of the sound, and the number of times it repeats, number of times it repeats are recorded. And then if you want to write one more, you can just say it records changes rather than the actual sounds. Thus preserving quality. Right. So reason for that is because run length encoding, it's to basically record the binary value of the sound and the number of time repeats to reduce the number of bits stored in that audio file. So it records changes of that particular audio file instead of recording, actual sounds inside the audio file itself. So instead of actually decreasing the audio quality, it decreases the number of bits used to store data that is stored inside the file itself. So this will reduce the size of the sound file. Right. So now we look at 8A. State whether the network will be a local area network. Okay, we have to look at the top first. School is setting up a network within one of its buildings, so you need to choose is LAN or WAN. So normally for school building, we normally will use local area network, right? So here we have to say local area network. Why? This is because school has a small geographical area. And it does not use internet. To transmit within the building. Right? So one classroom in the building has 30 computers. The computers need to be connected to the network. Each computer has an NIC or network interface card. Identify 2 possible devices that can be used to physically connect the 30 computers together. So 2 possible devices that can be used to physically connect 30 computers would be a switch or a hub. Normally routers, right? Normally for home routers, it's maximum of 4, but there may be other commercial grade routers that can handle more Ethernet ports and all those. So maybe there are more routers which can use to connect to multiple computers. So that can actually manage to handle all 30 computers at the same time. But most of the time, if you want to connect many computers together, we either use a switch or a hub. Most commonly right now we use switches because switches are it doesn't direct the data to every single device on its network, right? So yeah, that's the reason for that. And the school has several laptops. Each laptop has a wireless NIC. Describe the functions of a wireless NIC. So first, it allows the device to connect to the wireless network. So it provide interface to wireless network. Not only that, it receives analog radio waves, and convert them to digital form. It also encrypts and decrypts data. And we can put plus here. Also, it checks incoming transmissions for the correct IP address. Right, so this is the things that you can write. So first of all, it provides interface to a wireless network. It receives analog radio waves and convert them to digital form. It encrypts and decrypts data, and it also checks for incoming transmissions for the correct IP address. Right, so this is the function of a WNIC. Alright, so this is it for this paper. If you have any questions, do comment down below. Or if you want to, you can email me. You can also send an email to me at qiphyedu.com. I'll see you again in the next video for other past year papers. Till then.